Good morning, Math 7 students. This is Unit 3, Lesson 3, Combining Like Terms. So from our definitions from 3-1, you should know that like terms must have the same variables. And again, I put that S there because it could be one variable or it could be multiple ones. Must have the same variables and the same exponents. So remember from those definitions that variables are those letters and exponents are those smaller raised numbers. So keep that in mind. When we're looking at like terms, do they need to have the same coefficients? Well, does the definition of like terms say anything about them having the same coefficients? No, it specifically says that they need to have the same variables and the same exponents. So they do not need to have the same coefficients. So do they need the same coefficients? No. Same coefficients are not necessary. Okay, so in the following examples, we're going to determine if these are like terms or not, and we're going to write reasons for or why not. So, example 1, we have negative 110x and 2y. So are those like terms? Do they have the same variables and the same exponents? Well, they do have the same exponents. Each that x and that y, they both have a 1 on them, but they are not the same variables. They do not have both an x or both a y. So are these like terms? That would be no. No, because the variables are not the same. Okay, example 2. We have 4x and 4y. Are these like terms? They do have the same exponents and they do have the same coefficient, but remember that coefficient didn't matter. It didn't matter that we had the same coefficient or not. So these are also not like terms, again, because they have those different variables. No, because, and I'm just going to simplify this, different variables. Those coefficients don't matter. Example 3, 3x squared and negative 5x. At first glance, this might seem like terms because they do have the same variables. They both have an x to them, so that fits that category or that requirement. However, they do not have the same exponents. You'll see the first expression has an exponent of 2, and then the second expression has an exponent of 1 there because I don't see 1. So these are not like terms because they have different exponents. Those exponents don't line up. Example 4, 2xy and 7x. Again, at first glance, this might seem like terms, but it's actually not. Even though they all have exponents of 1, so the exponents are good, and even though they both have an x, a variable of x, the first term has a y attached to it, so the second term would also need that y attached to it. So these are not like terms because the 7x would also need a y. And finally, last but not least, this example 5, and this one is important. It's got a star next to it if you didn't realize this. This is an important example that we're going to look at, and it's going to come up in homework problems, practice problems quite frequently. So just be on the lookout. So negative 15xy and yx. So here, it's important important to be careful because there is a coefficient of 1 in front of that yx that we have there. I really didn't want to use orange again. So, do they have the same variables? Well, the negative 15 has an x and a y attached to it, and this other one has a y and an x, just in different order. So does that order matter? Does the order of the variables matter? Question mark. And let's look at that. If I think about xy versus yx, what operation is going on between the x and the y? Multiplication, because I don't see any. So if I were to pick a number for x and pick a number for y, let's say x is equal to 2 and let's say y is equal to 3 to make things easy. If I do 2 times 3, is that the same thing as doing 3 times 2? And it just so happens to be that it is. And that's because, again, with multiplication, we can switch that order around. 2 times 3 is the same thing as doing 3 times 2. So does the order of the variables matter? And the answer to that question is no, it doesn't. xy is equal to yx, keeping in mind that they do have the same exponents. Both the y and the x have an exponent of 1 because we don't see it there. So this, they are like terms. They both have x and y with exponents of 1. So they do fit into like terms.